Assalamu alaikum, sir. I am Jakaria Hussain Faisal, ID 171155956. As my previous member have already discussed about the advantage, disadvantage, or the basic description of our project, so my part is just to describe the circuit diagram and the working principle and some codes about the project in Arduino IDE. Here we have designed our project virtually in Proteus uh, simulator or Proteus software. Here we have used a solar panel having 12 volt. Here is the property, and there is also a DC motor of 12 volt, just having a load resistance of 12 ohm. And here this is a potentiometer. This potentiometer is actually variable. It's registered to 0 to 10 ohm. And here is the sensor. It's actually the current sensor's model is ACS712, and we have loaded the current sensor with a 5 volt power, and it's connected with the ground. So mainly the current sensor is actually sensing the current from the solar panel through the potentiometer, and the potentiometer and the solar is actually connected with the motor. So when we start simulating, the solar panel will produce current through the uh, potentiometer to the 12 volt DC motor, and in the meantime the current sensor ACS712 will capture the current and send it to our Arduino. And here our Arduino is connected with uh, the current sensor ACS712. Here is the uh, analog input, which is actually connected with the VI output of our current sensor. We know the current sensor actually produce the output in a analog way. And then we have connected a LCD screen, LCD display with our Arduino Uno. Here is the pin connection with the Arduino, and we have also connected an additional 5 volt supply uh, for the LCD display. So this is actually the main circuit diagram. So when we start simulating, it looks like this. Here the motor is actually rotating. Here the current through the solar panel is actually go through the potentiometer, and the current sensor is sensing the current and convert the current into voltage and power. We have done this calculation in Arduino IDE in coding part. And if we change the variable resistance to the potentiometer, then we can see that the voltage is now downgraded to 9 volt and the power is 5 watt, which was previously 12 volt and 12 watt. Now this is 5 volt, 9 volt and 5 watt. If we increase the resistance more, we know the voltage will also reduce and the power will also reduce. So actually we have used a potentiometer because we cannot show the light which is actually impacted on the solar panel uh, in different time in a day. We cannot visualize that. That's why we need to use a potentiometer to sense to visualize the difference in current and voltage and power. And this is actually the main circuit diagram of our project. Now I'm going to show the coding part, what we have done in Arduino IDE. Here is the coding part. First of all, we have included the liquid crystal header file for the LCD display, and then we have created a LCD object through the 11 10 5 4 3 2 these pins, because we have used these pins from Arduino to connect with our LCD. And then we have configured some value. I will discuss about it accordingly. Uh, in our setup method, we have just started the LCD begin with 16 to 16 in basically the columns, and 2 is basically the row, the number of lines in our LCD. ADC value analog read, this is mainly reading the analog value from A0 port, which is actually the output of our ACS current sensor. This is actually the analog value, and this is in a range of 0 to 1024. And if we divided this value with 1024 and multiply it 5k, because we know our ACS 712 current sensor is actually connected with a 5 volt DC power. That's why we have to multiply this with 5000, because this value is actually in milliform. So this ADC voltage is actually a millivoltage form, and this is the voltage which is actually produced, which is actually sensed by the ACS current sensor. And this value, ADC voltage, we will reduce the offset voltage. What is the offset voltage? Offset voltage is actually the half of our voltage applied in our current sensor. We know 5 volt is applied in our current sensor, and if there is no external power like solar panel, then at least 2 volt, 2.5 volt will sense by the current sensor. That's why we need to multiply. Well, that's why we need to subtract the offset voltage, and this offset voltage is actually 2.5 volt, and 2.5 volt is actually 25,000 in millivoltage. And when we need to calculate the current, then actually we need to divide the voltage by the sensitivity. Sensitivity is actually the internal load voltage, load resistance in our current sensor. So uh, when we use the AC712 current sensor, it's actually can calculate the current up to 30 ampere. So the internal resistance of this current sensor is actually 66 ohm. So we need to divide the 66 by the voltage. So voltage divided by resistance is actually the current. So we got the final current of our circuit, or we got the current of our power source or our solar panel. And when we multiply the resistance, which is 12, this is actually the load resistance of our motor here, the 12 ohm. When we divide it, when we multiply this resistance with the current, then we got the load voltage which is actually applied by the solar panel. And finally the power is actually, we know P equal to uh, V into I square. That's why we have multiplied voltage into current twice, and we got the power in watt. And finally, in our LCD print, we have printed the current, the voltage, and the power sequentially. And this is all about our coding part. I want to add something. We didn't apply any kind of Wi-Fi module or any kind of internet devices. As we know that our project is actually IoT based project, but there have some limitation in Proteus or in virtual devices. We know the difficulty or the security issues using a network device is actually too much high in nowadays. So actually most of the softwares like Proteus or Tinkercad, they are actually discarding or discouraging us to using the network devices. The only thing we can do is we can connect a physical device with our system, and we can sense that, we can demo that thing in our virtual model, and we can work through that. But in this situation, in this pandemic, it's actually very tough for us to collect the actual ASP8266 Wi-Fi module and work with the ThingSpeak. What was actually our plan, but this is not possible because we don't have the device in our hand, and virtually the implementation of Wi-Fi or any Ethernet device is kind of impossible to us. It can be done, but we have tried our best, and this is the final result, what we have concluded. That's all from my side. Thank you, sir. Thank you, everyone.